Hi everyone, so in today's video we're going to have a look at paper and card for AQA A-Level product design. So typically this will be on paper 1, the 2.5 hour paper. So in terms of what you need to know in the content for paper and card is the different types of paper and card and the properties that they have, the stock forms that they come in, how it's formed, how it's printed, and then how to select the right material for what you want. Now, the formed and printed parts of what you need to know will be covered in another video when we actually look at forming processes as a video. In fact, that's already up on the YouTube channel already, so do have a look at that. So the main thing we're going to look at is the different types of paper and card and then the stock forms that they come in as well. So if you've already watched the videos in order, with metals, plastics and timbers, we talked about understanding you can't just say something's made out of paper or card or metal or wood, because that gives you no marks. And the way you specify what specific material you want depends on the properties that it has. And typically in exam questions they'll use statements like explain why this material is suitable for this job. So explain why this card is suitable for high-end packaging, or explain why this paper is suitable for textbooks. So they've been specific of the use, and the properties of those specific types of paper and card make it more or less suitable depending on what it is. Obviously, with paper and card, they don't have the same types of properties as woods, metals and plastics. You don't have things like tensile strength or elasticity or conductive strength or anything like that. This is more, generally they are what known as compliant materials. So what that means is that you can cut it, you can score it, you can fold it. So like things with craft knives, you can cut into a net, you can fold it over, that type of thing. Also, please do avoid sweeping statements where you just say, oh, it's paper, it's card, it means it can all be recycled. Because normal paper that you see on a regular basis, like A4 line paper, that can be recycled. So most can be recycled, but actually as soon as you start mixing more than one material together, so as soon as you laminate something or you print onto it, it then starts to make it very difficult to recycle. And once you make something difficult to recycle, it will then just be chucked and set in a landfill. Now actually most paper products, or pretty much all, will biodegrade quite quickly, so it's not a big issue, but some of them can't be recycled once they've been coated, like a wax coating or something like that. So just try and avoid sweeping statements like it can be recycled, or it's just paper, or it's just card. So the first thing to point out is what we've got written at the top up here is GSM. So what that stands for is grams per square meter. So that is basically how paper or card is measured, how it is defined. So the magic number, now if you, depending on where you look, this number will be different. Some sources say it's 200, the textbook says it's 220. Basically anything under 220 grams per square meter is classed as paper. Anything over 220 GSM is classed as board or card. So there are plenty of different types of paper. So everything on here now is considered paper because it's under 220 GSM. If you've done fine art or anything like that, some of these will be more familiar to you. So things, let's go with like layout paper. If you've ever had like a little sketch pad, like the one you got here, so thin translucent paper, so you can kind of see through it a little bit, nice smooth surface, really good for sketching, technical drawing, and you can trace over it a little bit as well. You've then got cartridge paper. So you should have a sketchbook in A-Level product design. It's one of the requirements that you need to bring with the course. And it's that paper that's basically a little bit bumpy, like texture to it, not quite white, a little bit creamy sort of colour, and it's perfect for sketching and rendering with pastels and pencils, not pens because it will bleed a little bit, but it's ideal for sketching. Next you've got treated paper. So this is treated paper that you can make, basically a paper that you can basically make it so it can have a matte or a gloss finish that you can print photographs on and make it really, really nice, have a nice, good quality, clean photo finish. Next you've got watercolour paper. So this is available in absorbent or smooth. So it is heavily textured. And basically watercolour, it will allow you to do watercolour painting, so it won't bleed the ink the paint at all. It will hold the paint very, very well. And then you've got bleed proof paper. which is similar to cartridge paper but has bleed-proof layer on it. So what I said with cartridge paper is you would render in pencils and pencil colours, but not pen because it would bleed. Bleeding is essentially if you ever get like a say a Sharpie pen or a fountain pen, and if you just hold the nib of the pen onto the paper, and the ink starts to disperse around the page, that's bleeding. Bleed-proof paper essentially stops that from happening, because some people really like rendering with pens as opposed to pencils, and obviously you can't do that with cartridge paper, but you can do it with bleed-proof paper instead. So we've then got metal effect card. So this is a really high quality thin piece of card that has got a metal surface over the top of it. It normally has a very high end sort of look to it. You can emboss on it. So embossing and debossing. So embossing is when you have like the lettering sticking up. Debossing is when you have the lettering sticking down and it's basically pressed into it. So typically it's used for things like gift boxes or really high end packaging. Also, it's quite fancy business cards and those types of things as well. When we talked about how things can be recycled or not, because you've basically covered something in a thin layer of metal, this now cannot be recycled because you've mixed more than one material together and it becomes quite challenging to do. Then down at the bottom, we've got duplex board. The duplex board is made of 2 layers of paper, where the outside one is more water resistant to give it a glossy look and a bit of a waxy feel. That makes it quite difficult to recycle. It's used quite a lot in like things like food packaging, like juice cartons. If you get your milk out of cartons, I suppose, or bottles, those types of things. So it's waterproof. You can print on it, so it's really good. But yeah, because you got the waxy sort of glossy thing, it makes it a bit more difficult to recycle. And then you've got full back and laminated card. So similar sort of way, is it's waterproof. Excuse me. So it's covered with a plastic film or foil over it, so normally on the interior at least, and it's sort of insulated because that'll essentially, if you've ever had like a carton of orange juice, you see on the inside it's sort of like silvery. That's what that will be. It keeps things fresh. If you're going to recycle it, you need to actually remove that foil, which they do tend to do now. There's a bit more easier way of doing it. So a couple of overlaps with duplex board and foil back card in terms of like drinks packaging and that type of thing. The more common one will be foil backed and laminated card for your orange juice, your apple juice sort of cartons, those types of things. So now we're going to over 220 GSM, so over 220 grams per square meter. So this is now considered card. So the first one is corrugated card. So this is one really common. Most people, when they think of card, they just say this is what they're thinking. So what it has got, if you can see on the moving section here, is basically like little waves on the interior of it. So you've got 2 layers of it, and then the middle layer. And what that does is essentially protects it from impact. And that doesn't mean that you can run something over your car or you can throw it out the top story of a building, but it does give it a bit of like suspension, a bit of protection if you were to knock into something a little bit. So it's used quite a lot for protective packaging. It's also very useful for prototype making, particularly at A-level in like quick little models, bit of glue gun, knife, and then you can make models pretty well with it actually. Molded paper pulp, which we've got down at the bottom here. So if you've ever been to a drive-through, go for like your Mackies or whatever, your drinks will normally come in something like this. It is very eco-friendly because it's literally just recycled paper pulp, and it's just dried and molded into a specific shape. Excuse me. It's used for like egg boxes as well, and also some electronics. It's not bleached or treated or anything like that because it doesn't need to look nice. It's literally just effective, eco-friendly packaging that can hold things in place. So it's actually used quite a lot. Next, you've got bleached card. So it's almost the exact opposite of molded paper pulp. Once you've got your pulp and you're making the paper, typically you will bleach it to give it a certain look. So with bleached card, it's treated to make it like a really bright surface, so you can do really good quality printing on it. So when you buy like your birthday cards and things like that, that's what you're getting. And then mount board, which is compressed fine cotton fibres that makes they compress quite a lot to make a rigid board that is typically used for presenting artwork. So if you go to university and do exhibitions and that sort of thing, that's the kind of card that you will have. So these ones here are a little bit different. So these aren't actually paper or board, but they're actually polymer-based sheets. And they're still considered like compliant material. So the first one, LDPE sheet. Now LDPE, again, if you've already seen the plastics video, stands for low density polyethylene. So it's very tough, comes in thin sheets, and there's really good chemical resistance. So it's used quite a lot for food wrapping, think like cling film, that sort of thing. Air pillow packaging, so that is obviously back in the day they used to have like the styrofoam peanuts. But nowadays if you buy things and you get like the little bags of air that essentially stop things from breaking, so that's what that is. And then it's dead easy to recycle. And plastic carrier bags as well. Then you've got Plastizote foam, which is a closed cell polyethylene foam, which is really tough, really flexible, and good impact resistance. And that is pretty much what every single swimming float um, that you have, so you're like the pool noodle or the little float that you used to learn how to swim on. That's what all those are made out of. Gym exercise mats, the little martial arts mats like the interlocking mats, those sort of things. And then they're also really good for sound and pipe insulation as well. Then you've got cellulose acetate, which is transparent, tough, and it naturally biodegrades really well. So that is used for packaging film and photographic film. And pretty much the same thing with polylactide, which is the same thing, pretty much transparent, tough, naturally biodegrades, and again, it's just biodegradable packaging film. So these are used being used a lot more because they biodegrade quite well. So you've then got foam board, which some of you may have worked in before. It's really, really good for architectural models. So you got two outside layers of card, and then in the middle is foam, and you can get it in loads of different thicknesses. And essentially, you'll just score it with a knife. You can fold it over. You can make some very, very detailed models, as you can see. It's not just used for architecture models. You can use it in the prototyping, but its most common use probably is things like architecture models. Next, you got fluted PP. Now, PP stands for polypropylene. So essentially, those flutes are almost like corrugations, like with corrugated cards. If you look on this picture on the right, basically you got these little like channels, I guess you could call them, which make it quite a rigid piece of plastic. They're really good to work in. They are using things like construction site signs, estate agent signs, those types of things. You can make boxes from them because they're quite lightweight, and they're okay for prototype model making. Not quite as good as foam board, but they're quite rigid. You're pretty easy to cut and score and mold and those sorts of things. Then you've got translucent polypropylene sheet. So it's a very tough polymer sheet. So you can score it, so you can bend it. So by scoring, essentially what we mean is you can cut into it, but you don't cut all the way into it. You sort of cut like a third of the way or half of the way, and then you can sort of bend it, and that'll make it almost like a hinge. Polypropylene sheet, and I have some in the workshop, is almost impossible to tear, and it's completely water resistant, so it's really good for some things. I use a lot for packaging, folders. You might use it a little bit in modelling sometimes. And then styrofoam, which is dense, close cell form. You probably know it as being blue modelling foam. If you ever used it in secondary school, typically now it doesn't come in blue. For some reason, it's now grey modelling foam. That's what we use in the first year to do your prototype modelling in your workshop induction. And main use really is for prototyping. It's perfect because it's a compliant material. You can score it. You can pretty much use every single workshop tool with it. You can sand it. You can file it. You can cut it. So it's got a lot of good uses in prototyping. So stock forms. So stock forms, simply put, are essentially the standard uniform sizes that materials can come in. There's a reason why you can't just go into a shop and go, oh, I need a piece of paper, it's loads of paper that is 216 centimeters by 11 centimeters wide, because people will look at you like you're insane. The whole reason why you have stock forms and uniform sizes is that it just makes it a lot easier to manage materials. You know how to how to order everything. So you go from A0 all the way down to A6. So the bigger the number, the smaller it is. The most common thing you probably use is A4 for things like your sketchbooks and notepads, and then A3 when you're doing bigger bits of drawing. If you do art, you may well use an A2 or an A1. There are slightly bigger ones, which are SRAs. So they're for commercial use, and the reason why they're slightly bigger is that it allows for bleeding over the edge. So if you imagine when you're printing it on a big like blotter cutter, or blotter printer, sorry. So you imagine your paper here, the edges, so the ink will overspill, and then you'll trim around the edges so you get a nice finish to it. You can also do things like laminating, so you're adding strength material by sort of fold backing it, or you're going to add protective layer over it, so it means it will last a bit longer. Okay, so now what we're going to do is have a look at breakdown of some questions. So I'll have the question on the board, or the screen rather. I'll go through the breakdown of it, pause the video, and have a go at answering them yourselves. So the first one, for each of the following materials, explain in detail why it's suitable for a product listed in the table below. Your answers should make reference to function, aesthetics, and manufacture. So shape memory alloy for braces, photo quality cartridge paper for point of sale, and then polymer for modelling a toothbrush handle. So first thing, so we're going to try and break it down. So it's already told you what it wants you to write about. So that's function, aesthetics, and manufacture. Now remember that it's talked about explaining in detail why it's suitable. So anytime it's saying why is something suitable, like why is a material suitable, that's your sign to talk about the material's properties themselves and how they relate to the function, the aesthetics, and the manufacture of whatever the thing is. So there's 3 things you've got to write about. Each one is worth 6 marks. So actually it's worth quite a lot of marks overall. But each one's 6 marks, so realistically you need to come up with 3 points and then explain each one of those points gets you 6 marks in total. If some of them you're not sure about, start to have educated guesses. Don't just leave things blank. So for example, if you take like a point of sale display, you know the whole purpose of it is to attract customers. So it needs to look nice, and it also needs to be easily mass produced, because you don't just make like one promotional stand, you make thousands and thousands. So pause the video, give yourself 18 minutes, fast maths for you right there, answer the question and then unpause it and we'll go for the answers. Okay, so I won't go through all of it, I'll leave this on the screen while we talk through a little bit. So SMA, so ship memory alloys, so they react to the temperature, so the braces will tighten and set the teeth better based on the body temperature of your mouth. It's an inert material, so it won't corrode, it won't react to liquids, it won't poison, it won't harm the person, so it doesn't matter if it's internal and inside the human body. And it's a non-toxic material, so it's not going to hurt anyone. Photo quality paper, so it's a high gloss, so it gives a nice professional quality look. It can be laminated on the card and paper, so you can give it more rigid strength to it. It's from a sustainable source, so actually it doesn't have an environmental impact that much. It's kept to quite a minimal. It's pretty easy to recycle for the most part. It's just then if you were to start laminating it onto something, then it'd be a little bit more difficult to recycle. And polymorph requires a pretty low heat, and then it's really easy to shape. So it gives you a really nice finish, and it's kind of similar to if you were to injection mold it, but you can do it without all the equipment, without all the cost, and then you can paint it to get a nice, good quality finish as well. So match each of the following compliant materials to the correct application in the table below: layout paper, styrofoam, acetate, and bleed-proof paper. So there's that word compliant again. So that's basically materials that can be, cut, scored, formed. Dead simple multiple choice. Just read through it carefully. You can only use each answer once. Give yourself, I'll say 2 minutes, and then we'll go for the answers. Okay, so modelling, styrofoam, sketching, you could have layout paper or bleed-proof paper depending on what you're doing. Marker rendering, it could only be bleed-proof paper. So bleed-proof paper could be 1 in 2 answers, but layout paper can only be for sketching. And then for retail packaging, with clear window would be acetates. That's how like you can see like toys and things like that that's still sticking out as a part of promotion. Name the specific type of card used in making brown packaging boxes. State 2 reasons why this card is used. Oh, sorry. So pause the video, give yourself 3 minutes, and we'll go through. So you used to have carton board. You could also accept corrugated card or flute card would be fine as well. Carton is used because it can be recycled, because boxes have quite a short lifespan, inexpensive, and can be mass produced. You could have said the same for cardboard, but as well as it's relatively cheap. It is really easy to mass produce. It's really easy to recycle. You could also say that it adds some protection to the product as well. So there's a couple of possible right answers you could have had there. So a carton suit company are producing 200 units of prototype packaging. Select an appropriate printing process for this packaging and explain why it is suitable. So 6 marks. So basically what they're saying is, okay, how can you, and it doesn't matter if you've got images or anything, this is the second part of the question. So basically, you're going to make 2,000 of something. So you need a process that will let you print or make 2,000 of a thing as well as possible. Okay, so this is to do with the actual printing process. So 6 marks. Give yourself 6 minutes, and then we'll go for the answers. So what you'd have really looking at digital printing or like inkjet or laser printing, which are the most common ones. So it's good, high quality, consistent colour. Speed, obviously, it says we're mass producing, we're making 2,000. You need to make as many as possible. Um, things like the economy of scale. So what that means is basically it costs a lot to begin with, but then once you've got it, you've got it, and then the more you make, the less it costs you. So you're actually not making money quite quickly. It doesn't take long to set up. You can change the colours nice and easily. There's no specific tools required or anything like that. You don't need any specific equipment, and it's really easy to modify. So quite simple. I know we didn't go through printing in this particular video, and it is in another video, but you will find there will be some overlap. Obviously, paper and card, and this is a paper and card related part of a question, but it's just not part of what we've covered in this video. But you will find that sometimes. Okay, so that is the end of the paper and card revision video. In the lesson, we'll then go through more questions in more detail. If you've got any questions about this particular video, please let me know and I'll get back to you.